Application of total internal reflection. For glass, the refractive index is 3 by 2, that is 1.5. The value of refractive is 1.5. Since sine of C is equal to 1 by mu for the total internal reflection to take place, C, that is the angle of incidence, should be greater than C for total internal reflection to take place. It means for glass, refractant is 3 by 3.2. So sine of C is equal to 1 by refractive index of glass is 1.5, which is equal to 0.667, or C is equal to sine inverse 0.667, whose value comes out to be 41.8 degree. That is approximately, we can take it as 42 degree. Therefore, the critical angle for glass is 42 degree. If any ray incident at any phase undergoes refraction, it will not undergo reflection. The refraction, it will suffer total internal reflection. It means when angle of incidence is greater than C, that is I is greater than 42 degree, then the ray will be totally internally reflected as far as the glass is concerned. So we take right angle prism. At this condition, the prism will become totally internally reflecting prism. That is, it is the right angle isosceles prism. Right angle isosceles prism means right angle isosceles prism become reflecting prism if the angle of incidence is greater than 42 degree. Let us take here right angle isosceles triangle. That is, angle will be 45, the three angle 90, 45. This is called right angle isosceles prism. This is the right angle prism. Say this is side A, this is side B and side C. When a ray is normally incident at this point, at phase AB, and after refraction through this phase, it will go undeviated, because the angle of incident and normal are same. The angle between normal and angle of incident is 0, so it means angle of incident at this phase is equal to 0, and it goes undeviated. Here also it will be 90 degree. Since it is 90 degree and this is 45, right angle triangle 90 degree and 45, the same angle will be here, and right goes undeviated. So at this point we draw the normal. This is a glass prism 45 degree, and the angle between this and this is equal to 90. If this is 45, this will be 45 degree. It means the 45 degree angle of incident at this phase, is equal to 45 degree, which is greater than 42 degree. It means which is the angle of incidence is greater than critical angle. Critical angle is 42 for glass. So it means it will not suffer, it will not undergo refraction and emerge out. It will totally internally reflected, because of this angle of incidence is greater than critical angle. So it means it will undergo reflection, total internal reflection. It means this is the angle of incidence at this point, and with respect to normal, it will exactly undergo 45 degree as angle of reflection, because the angle is with respect to normal, it will be, this is reflected ray, it undergoes TIR, total internal reflection, and at this surface, since the angle of incidence is equal to 0, here I is equal to 0, so angle of refraction will be also equal to 0. Angle of refraction is also equal to 0. So the light will undergo refraction at this phase with a 0 angle of incidence and 0 angle of refraction. It will undergo total internal reflection at this phase because the angle of incidence is 45 degree, which is greater than critical angle, and exactly with the same angle of incidence it will be reflected, and here it will be refracted, but it will go undeviated. In this way, the ray is going this way, it is deviated this way. The angle between incident and emergent ray is 90 degrees. So it is that therefore the rays can be diverted 90 degrees. Right angle isosceles prism can be used to direct the rays 90 degrees. As a right angle isosceles prism is totally right angle prism, that is 45, 90, 45 degree, it is used to deviate the rays through 90 degree. And if you take one more ray like this, it will also undergo the same process, and if it is the object A, B, and this way it will go this way. So this is the image form. So the A is here, A, and B is here. It means the image is AB, which is which is rotated through an angle of 90 degree by using the right angle isosceles prism. That is AB, side AB is equal to side BC. This is right angle isosceles prism, which also can be called as deviating prism, total internal reflection prism. To deviate the ray or object through 180 degree, we use reflecting prism, that is right angle isosceles prism. Let us take a right angle isosceles prism. This is a 90 degree, this is 45 degree, this is 45 degree. Since it is isosceles triangle, two sides, it means the side here, the side opposite, the 45 opposite side, both will be equal in size. That is face AC and face AB are isosceles side. Both the sides are equal, and this is 90 degree. That is the angle is 45, 90, 45. This is called right angle isosceles prism or reflecting prism. When a ray goes from here, when a ray goes, the angle of incidence is equal to 0 here, and angle of refraction also will be 0 here. Then at this point we draw the normal. Since this is 90 and this is 45, this will be 45. If this is 45, this is 90, this will be 45. Since it is 45, the angle of incidence, at phase BA is 45 degree, which is greater than critical angle, that is 42 degree of glass. Therefore, angle of incidence is greater than critical angle, which the critical angle for glass prism is 42 degree. So therefore, this ray will suffer total internal reflection. It will not emerge out of this face AB. It will undergo So it means whatever the angle of incidence with respect to normal the incident ray makes is called angle of incidence. Exactly the same angle it will be reflected. It will be reflected because this is 45, this is 90 degree, this is 45. Exactly whatever the angle of incidence, same will be the angle of reflection. The rays goes this way. Again, at this phase, this is normal. Since this is normal, this is 90 degree, so it will also undergoes this angle of incidence here. What is angle of incidence here? This is normal and this is 90 degree. If this is 45, this will be also with respect to this will be also 45. If this is 45, this is 90, this will definitely be 45. And this angle between this line and this line is 90 and this is 45, this will be also 45. Since it is 45, which is greater than the critical angle at this phase AC, so the ray at this phase AC will undergo total internal reflection because of the angle of incidence is greater than the critical angle of the glass material, which is out of which the prism is made of. So it means exactly at angle of incidence it will be reflected at 45 degree, which is angle of refraction. So this will be also 45 degree. The ray will come like this. Since it is normally incident at this phase BC, it will go undeviated without any. This way, a ray which is passed through an isosceles triangle, it is deviated through 180 degree. The ray is deviated through 180 degree. Since the ray is going this way, it comes up this way. So it is deviated by 180 degree. Now another ray, we take another ray like this, which is going from here like this. At incident, it will also undergo the same process. It means suppose if the object is kept like this, this is A, this is B, the ray goes here, the rays goes here, A will come here, A dash, B goes this way and comes here. So this will be B dash. In this way, though the figure is not exactly right, both the size of the object and image will be same. So the object is kept this way, in this fashion, and it is inverted through 180 degree. B dash, A dash, and this is B, A. So this way, by using application of total internal reflection by a right angle isosceles prism, we can deviate the ray through 180 degree, or we can deviate the object, invert the object, we can deviate the object through an angle of 180 degree. Application of total internal reflection by using the same right angle isosceles prism, that is reflecting prism, we can invert the image of an object without changing in size. Let us see how it is. This is an isosceles prism. Right angle at this one, this is 45 degree and this is 45 degree and this is 90 degree. See, A, B, C. A ray falling at this point, ray is coming this way and falling at interface AB, it will go undeviated because the angle of deviation, angle of incidence is equal to 0 because falling perpendicular to this face, and so it will go undeviated because angle of reflection also will be 0. At this when it is falling here, this is 45 and this is 90. Obviously this will be 45 because sum of all the angles of a triangle is equal to 180. So this is 90, this will be 45, and we draw a normal here. When we draw the normal, and since this is 90 degree and this is, suppose this is 90, 45, it will be 45 degree, and the angle, this angle is equal to 90, so obviously this will be also 45 degree. 45 degree, it means the angle of incidence at the face BC is equal to 45 degrees, which is equal to 45 degree, this angle. So it means it is the angle of incidence is greater than the critical angle of the prism. Since critical angle of the prism is equal to 42 degree approximately, so it will be, this ray will suffer, the ray will suffer total internal refraction, as the angle of incidence, that is angle between normal and the incident is 45 degree, it will undergo TAR. It means exactly in the same angle it will be reflected. As angle of incidence, it will be the same angle, it will be reflected. It will not go refraction. Again, at this phase, the ray is falling normal to this phase, it will go undeviated. So it means the ray, suppose this is A, this point is A, and one more ray parallel to this will also undergo the same process. It will also undergo and same thing will happen, and this ray and this ray are parallel. So though it is not exactly to the scale, we assume that both the rays, all the rays are, these two rays are parallel after refraction through this one, after refraction through this one, after refraction to the face AC. So if it is, images like object is kept like this, A, B. Object is kept in this way, A will go this way and this way, this will be A dash, and B will come this way and this will be B dash, that is image, and A to B. It means the image object is kept this way and it is inverted like this by 180 degree. This way, by using right angle isosceles prism, that is reflecting prism, we can invert the image of an object without changing its size.